Questions. Before we talk about angles in degree, okay, there are two units for angles. So one is degree, and the other one, like, I'm not sure if you have learned it last year. If you're not, like, that's a new thing for you. It's called radian. Okay, we have degree mode and radian mode. So it will be the same as when we talk about the lengths. We have meters and centimeters and kilometers. But for degrees, for angles, we have degree and radian. So in year 10, before year 10, we focus on degree. Like, this angle is 120 degrees, this angle is 60 degrees. We focus on degree. But come to year 11, year 12, I think year 11 is not that obvious, but for year 12, all the things was converted into radian form. Okay, everything will be converted into radian form. So that's something I want to talk about at the start of the class. It's about your calculator. So if you go to your home page for the calculator, in the setting function, okay, in the setting, and if you go to document setting, okay, this is the front page. This is the page that control calculator, okay, when you do calculations, the calculator. So for number 2, and you can see the second line, I put this into the radian form. Okay, I put this into the radian form. But if you meet degree, I'll talk about if you see degrees, what you should do, like later when we evaluate sine and cosine. But after year 12, if you don't learn further, I think further will use degree. If you learn further, further will use degree. And this will be changed into degree when you do further questions. And you need to remember to change it back when you do methods. So it's 2 different units for... I can't say it's 100% radian for method, because in some cases it use degree as well. So remember to change the settings when you meet different questions. So that's the place you need to change it. So see, for my calculator, I just keep it in the radian form because I only do method. I will press the make default and press OK. Then when you turn it off and then turn it on, it will still stay in radian form. If you just press OK, I think it will change it back after you turn it off. But that's not the only place you need to change it. This only control the calculator, like only control this. But if you open the graphing page, okay, if you open the graphing page and go menu and number 9 setting, there's another place control the graphing as well. So radian form, okay, I will keep in radian. You only use radian and degree. I'm not sure what's the gradient used for, but we only do radian and degree. So I put in radian form and I press make default. Maybe it's a little bit early for year 11 level to do it, but like year 12, you definitely need to put in radian form. And that's a very important thing. If your setting is wrong, every calculation will be incorrect. Okay, every calculation will be incorrect if you put the setting wrong. That actually happens in exam for the students I know. Like, they set into the wrong form and they can't graph out anything. They can't see the graph is a straight line. So very important setting for calculator. 2 places, one in the home page and the other one is in the calculator page. Okay, so now I'll explain what is degree and what is radian. Okay, what is degree and what is radian? First of all, we talk about something called unit circle. So what is unit circle? Unit circle is radius of 1. Okay, radius of 1. Let's draw a unit circle first. Okay, we treat this circle as radius of 1. That's a unit circle. So unit circle is the circle with radius 1. Okay, so 1 unit. Okay, what's the circumference for this circle? What's C equals to? 2 pi. Okay, 2 pi. Another question is, in degree, where's my pen? In degree, what's this angle? 360 degrees. Okay, 360 degrees. Now I'll introduce another unit. So the unit is called 1 radian. Okay, so 1 radian. So you know how much is 1 degree, right? If you cut this circle, like cut this angle into 160 even parts, and then one part will be 1 degree, right? 360, you cut evenly 360, you know that much is 1 degree. Okay, now what is 1 radian? How large is 1 radian? 1 radian is the angle subtended at the center of the unit circle by an arc length of 1 unit. Okay, so it's a long sentence, but I'll sketch it for you. So I'll make the unit circle bigger. An angle subtended at the center, it will be an angle like this. Okay, this is called the angle subtended at the center. But the requirement is with an arc length of 1 unit. So what is arc length of 1 unit? So here is arc length. Okay, this length is 1 unit. Okay, then this angle is called 1 radian. So it's 1c. You know degree is the circle on the right corner, but 1c is the angle for the angle we talk about for radian, the unit we use for radian. Okay, so how long is that? I'm not 100% sure, but like say 1 unit, you know, like calculator can measure that. So 1 unit, an angle subtended there, and then that angle we'll call 1 radian. So now I'm sketching another one. Okay, what's the size of this angle if I said this length is 5? 5 radian, good. So this angle we'll call 5 radian. So it's decided by the arc length. Okay, it's decided by the arc length. But this circle must be unit circle. Okay, now I want to ask about the question like this. So you know that's 5 radian, that's good. My next question is, I will use a bright color. Okay, so that's the center, right? And that's 1 radius, and that's another radius. What is the length here? What's this length? Pi, right? This length is pi. So what's this angle? Yes, Sarah?
Oh, I have a question.
Yes?
Are radians just relative to each other?
Sorry, again?
Are radians just relative to each other?
What do you mean by relative to each other?
Like, do radians have a set length or anything? Or like a set value?
1 radian? Do you mean 1 radian?
Yeah, but is that like a number? Is there any, but a radian can be any, like 1 step?
No, it's like a number. Like, it's like, do you know 1 degree? Like, do you understand 1 degree? 1 degree, say, is this big. So 1 radian is maybe this big.
Is it bigger than a degree or smaller than?
We can compare after you will see.
Okay.
After you can see what that means. So almost there. Okay, so the length here for this half circle is pi. So in radian form, what this angle is? Pi radian, right? Pi radian. So we'll say that's pi radian. Okay, in degree, what is this half circle? 180 degree, right? So now what we can see is pi radian equals to 180 degree. Okay, pi radian equals to 180 degree. Do you know what's pi? 3.14 something. Okay, so approximately 3 radian, right? Approximately 3 radian. Okay, Sarah, that's explaining which one is larger. That's approximately 3 radian. and that's approximately equals to 180 degrees because pi is 3.14. Okay, so 1 radian is approximately 60 degrees. So you can see which one is larger. Okay, you can see which one is larger. Well, that's approximately. You don't need to remember this approximately relationship. I'm just answering a question. Which one is larger? Definitely 1 degree is this much, but 1 radian is actually this much. It's quite big than 1 degree. So what's the actual relationship? Like, I don't really need this. What's the actual relationship? You can see 1 radian equals to 180 degrees divided by pi. And 1 degree will equals to pi radian divided by 180. Okay, that's the relationship you must remember. And that's how we convert between degree and radian. Okay, how we convert between degree and radian. So, let's do one example. Okay, I give you a table below here. So I will write 30 degrees here. I will put pi on 4 here. And pi on 3 here. And I will put next one will be 90 degrees and 120 degrees and 3 pi over 4 50 degrees and pi 270 degrees and 225 degrees. Okay, give you 5 minutes. Can you convert? Like you can see that's the degree mode, and the bottom is the radian mode. 225 degree. Up 225 degree here. Okay, so degree on top and radian at the bottom. I want you to convert the empty place, the empty box. So the first one, well, I'll do the first one with you. I'll do the first two with you. So 30 degrees. Now you can see is degree convert into radian. Degree convert into radian. So what we should do is 30 degrees times with pi over 180. Okay, is 30 times pi over 180. And you can see we cancel that. That's a 6. So we have a pi on 6 here.
When you have a number like pi on 4, is that pi radian on 4?
Yeah, pi radian on pi 4 on 4 radian like this.
Oh.
It doesn't really matter. Like it will be the same result even though it's pi radian divided by 4. Okay. Radian convert into degree is easy because what is pi? Pi equivalent to 180 degree, right? You can do by 2 ways. The first way we can do is pi over 4. Well, I will times by 180 over pi. That will convert into the degree. So that's 180 over 4 degree, and that is 45 degree. So here is 45 degree. Or another thing we can do is, you know that pi is equivalent to 180 degree, right? Pi is 180 degree. Pi radian is 180 degree. So I can directly change pi to 180 degree. Because it's pi radian over 4, so it's 180 degree over 4. It will be the same. They are equivalent. Pi and 180, they are the same thing. So that is 45 degree as well. Okay, just save one step. Okay, by using the same method, can you do the rest of it, please? Okay, I don't have much time, so 5 minutes. Okay, 5 minutes. What's pi on 3? 60? Okay, what's 90 degree? Okay, 120? Yeah. 3 pi on 4? 150? Pi? 225? And 270? Yep, good. All of these, they are special angles. You'll learn what are special angles later, but you need to familiar with all those pi's, okay? When I mentioned 5 pi on 6, you should know where is it and what's the size of it. Okay, so that needs time to convert between that. But like one thing I want to tell you is, I know a lot of students, they never learn radian, they only think about degree. They will only, when they see radian every time, they convert that into degree. That's a very slow way to do things, and you shouldn't do that. You should see, okay, pi is like, for example, 3 pi over 4, where is it? You should know where is it and what you should do. I'll talk about that more later, but do not think about converting all the time. Okay, you treat pi as an angle and you talk about where is it instead of converting that into degree. I'll talk about that more. But let's go to next page. Next page is the definition, which is really important. Okay. You know, like when we talk about sine, cosine, and tangent in year 10, all the time we talk about in right angle triangle. Okay, all the time we talk about those sine, cosine, and tangent values in right angle triangle. So you will only have angle in between 0 to 90 degrees. You won't get angle below 0 and you won't get angle beyond 90 degrees. But you know, in the real world, we have angles for 2 to 5 degrees. So what sine 2 to 5 degrees represent? What's the size of sine of 2 to 5 degrees? So sine, cosine, and tangent is not really only talk about in the right angle triangle. It can be defined by almost all the angles. So it's not really, the meaning is not really the opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. They're not really defined by that. So how sine and cosine and tangent really be defined is by unit circle. So what is unit circle? I have explained already. It's a circle with length, radius length of 1. But we put that into the Cartesian plane. So we center the circle at 0, 0, and with a radius of 1. So now you can see something like this. Okay, you can see something like this. It's not much space for me to sketch it. I will sketch it here. Okay, so we have XY axis, and I will sketch a unit circle. My unit circle looks very terrible, but you treat it as a circle, okay? That's a circle with radius of 1. Okay. Well, it's really not a circle, but anyway. Give me an angle, like any angle. 50? Okay, 50 degrees. So where is it? Okay, how we measure angles in the Cartesian plane. We start from the positive side of axis, like the positive, that's 0. Okay, that's where is 0. And then we go anti-clockwise to measure. Okay, anti-clockwise to measure. So it will be in the first quadrant for 0 to 90 and go to the second quadrant from 90 to 180. And from 180 to 70 is the third quadrant, and 270 back to the original place is to 360. But it not only go one cycle, it can go another time. So you can keep rotating anti-clockwise, and it will be 360 plus 90 plus and go forever. Like it can be any angle. But the position of 0 degrees and 360 degrees will be the same place. And all the properties of those two angles will be exactly the same. Yes? Yes. If you go for clockwise, that will be negative. Okay, so if you draw angle here, that angle will be this way. Okay, if you see it clockwise, that's a negative 45 degrees. But you can also see it for anti-clockwise. That's 360 minus 45 degree positive. So that's 315 degrees positive. So you can either say it's 315 degrees positive, or you can say it's negative 45 degree negative. And even though there are two different angles, but they locate at the same place, then all the properties, everything will be exactly the same for those two angles. So if angles are located at the same place, then all the sine, cosine, tangent value for that angle will be exactly the same. Okay, we get that? Okay, now back to what I was to say before. I said you give me angle like you give me 50 degrees. So can you on your thing, can you draw a 50-degree angle approximately? Okay, I draw a 50-degree angle for me. Okay, so go a little bit longer, but you won't go to the other side. Okay, start from 0, 0, but won't go beyond that 0, 0. So only go the positive way. So it's measured from like this. Okay, measure from here to here. That's a 50 degree. So you measure it clockwise, anti-clockwise. That's a 50-degree angle. Okay, now interesting happened. You can see intersections, right? Doesn't matter what angle you give me, you will see intersections, right? Okay, they intersect here. Okay, do you think you can work out, well, not you, like, do you think someone can work out these coordinates? Yes, right? Yes. Well, yes, because I will say this circle with equation x squared plus y squared equals to 1. Because center 0, 0 and radius of 1. So that's the equation for the circle. And for this linear, that's y equals to tangent 50 degrees times x. Remember the m represents the tangent of the angle. So it's tangent 50 degrees of x. I have two variables, x and y. And I have the equation, two equations. So I can solve x and y, even though I can't solve it now. Like I don't know like the exact value, but I can solve it. Possible to solve out x and y. Okay, it's possible to solve out x and y, and it's a unique solution. And it's a unique solution. So the circle's equation doesn't change; it stays the same all the time. But like different angle will give you different lines, but you can always find the gradient, like the gradient of that linear, and it starts from 0, 0, so it's just y equals mx. So I can always find the linear equation. So I can always find out the intersection. The intersection is important. That's how we define sine and cosine. Okay, so I have intersection. Let's say that's a comma b. Okay, I assume we solve out x and y. The x value represents the cosine of this angle. And the y value represents sine of this angle. We get this? Yes? Like, this is, don't ask me why. That's defined. How sine and cosine was defined. That's how we say this is sine. What is sine? This is sine. Okay? Sine is when you draw a unit circle and then you draw any angle. The intersection we find, the x will treat as cosine of that angle and the y value treat as sine of that angle. Okay? This is the definition for sine and cosine. So what is tangent? Tangent is easy. Tangent is sine divided by cos. So tangent 50 is sine 50 divided by cosine 50. So which is the y value divided by the x value? Okay, which is the y value divided by the x value? So it's b over a. So it's the y coordinates divided by the x coordinates, and that gives you the tangent value. All right. Now, I will talk about the CAST thing. I will draw this. Okay, I'll draw this. Okay, I want a table like this. Okay, this is the first quadrant angle. This is the second quadrant angle. This is the third quadrant angle, and this is the fourth quadrant angle. Well, you know, like, if I just talk about 0 and 360 degrees to 360 degrees, first region angle will be 0 to 90 degrees, and second will be 90 to 180, and then 180 to 270, and then 270 to 360. Yeah, you only talk about 0 to 360, but you know there will be more angles in first quadrant, more angle in the second, can be negative values, can be positive, doesn't matter. Let's just talk about those values now. Okay, can you tell me, I want to put positive sign or negative sign into those boxes, okay? I want to see sign of that angle will be positive or negative in that, in this box, okay, sine and cosine. Okay, think about the any coordinates in the first quadrant. Are they positive or negative, or one positive, one negative? Both positive, right? Okay, doesn't matter where I intersect. They're always positive values. So sine is the y value and cosine is the x value. They will be both positive. If the angle is in the first quadrant, doesn't matter where they intersect, it will be always two positive values. Let's think about the angle in the second quadrant. What is positive, what is negative? In the second quadrant, all the coordinates. X is negative, y is positive. So x is negative, y is positive. So you will have this. Okay, in the third quadrant, what will happen? Both of them are negative because x and y are both negative in the third quadrant. How about the coordinates in the fourth quadrant? X is positive and y is negative. You have that. Okay, now think about tangent. Tangent is y divided by x. So what you can say about the sign here? The first quadrant. Positive. How about the second one? Yes, third one. And last one? Negative. Now what we can see here is, in the second quadrant, only sine is positive, the other two will be negative. In the third quadrant, only tangent is positive, others are negative. In the fourth quadrant, only cos is positive, all the rest is negative. And in the first quadrant, everything's positive. Yes? Okay, that's what we have. So therefore, we have something I will written here is called CAST. Okay, why is CAST? In the first quadrant, all positive. In the second quadrant, sine positive. In the third quadrant, tan positive. In the fourth quadrant, cos is positive. The rest is negative. Okay, how I remember this? I will tell you how to use this later. We don't use it yet. But how we remember it, how we remember this CST thing. Well, different teachers teach in different ways. I remember from the fourth quadrant and write anti-clockwise. That's the cast, CST, cast. But another teacher I know teach like remember from the first quadrant is O station to Caulfield. So O station to Caulfield. Okay, so that's another way to remember. Like you choose the way you think you can remember. It's but basically is write the correct letter into the correct quadrant. Okay. So what we have learned so far, okay, we learned the ASTC thing, like the cos thing, and we learned this is an important formula. Tangent theta will be sine theta divided by cos theta, and the cos value will represent by the x coordinates, and the sine value represent by the y coordinates. And the definition for sine and cosine. Now, what I teach you before is kind of useless because you can't work out the actual coordinates or say the coordinates is not really a nice value. So what I can do? What's this unit circle really used for in the test purpose? Okay, if you are in the test, why you need to know unit circle? Why you need to know what I have talked about so far? Okay, because there are first type of special angles. So I have two types of special angles. We talk about the first group today. So they are lies on the axis. Okay, it's the angle lies on the axis, which is 0, 90, 180, 270, 360. There are multiple of 90 degrees, or say multiple of pi on 2. Okay, so 0 is 0 degree, pi on 2 is 180 degree, 90 degree, and pi is 180 degree, and then 3 pi over 2 is 270 degrees. Okay, so how we remember that? In the circle, okay, 0 here, pi on 2. Another pi on 2, so it's pi, and another pi on 2 is 3 pi on 2. Okay, so that's how, like, each right angle is pi on 2. So 0 pi on 2, pi, 3 pi on 2, 2 pi, and then 5 pi on 2, and keep going. Now, why I said that's important? Let's just consider about this angle 0. Okay, this angle 0. Can you tell me what's this intersection? What's the coordinates of that intersection? 1, 0, right? 1, 0, because it's a radius of 1. So x represents cos or sine? Cos, and y represents sine. So now you know that cos value will be 1 and sine value will be 0. So sine divided by cos give you 10. Okay? That sine divided by cos give you 10, so you have 0 tangent. Okay, think about the next 90 degrees or pi on 2, which is here. What's the coordinates here? 0, 1, right? So y value represents sine, and cosine represent by the x value. So it's 1 and 0. Okay, what's the tangent value here? Undefined. 1 divided by 0. 1 divided by 0. So denominator is 0, so it's undefined. Okay, so it's undefined. Okay, 180. What's the coordinates here? 1, 0. So 0 will be the sine value and -1 will be the cosine value. What's the tangent? 0. Okay, what's the coordinates here? 0, -1. So -1 is the sine value and 0 is the cos value. Tangent? Undefined. Okay, they are the first type of special angles. No. Any questions first before I move on to the next question? Do you have any problems you want to ask? Okay, so unit circle, this method can only help you, okay, not like the others, like how they find all the values they use this method, but like we are not requiring you to find sine 50 for me. Okay, so you only need to know this method to evaluate angle on the axis, like 0, 90, 180, 270, 360, or -90, -pi, or -3/2. Okay? Okay, let's move on to the next question. Okay, we have 6 more questions to finish today. Okay, I will show you 1 and you do the other 5. Okay, -3/2, where is it? I will say, like, I have point A, B, C, D of the unit circle. Can you tell me which point? It's negative. Yeah. Let's have a look. -2, -pi, and -pi/2. So it's at that place. Okay, what's the coordinates of the intersection? 0, 1. 0, 1. So sine is the y value. So sine of that is 1.
Just multiply sine 3 times 2 by -1.
Why you times it by -1?
Because it's -2 and like sine 3 times.
Again, I don't get what you
So you have sine -3 pi.
Yeah?
You multiply sine 3 pi over 2 by -1.
Okay. For sine, yes, because of the rule. For cos, it's not. So you don't use that method.
Okay.
You don't use that method because some yes, some no. For tangent, maybe yes, maybe no. Like we haven't learned that yet. Okay, everyone, please do the other 5 by using the same method. Draw the angle, find the intersection, and then choose x or y divided by x.
Yeah, you have this.
Okay, you have 5 minutes to do that.